So this is about what the department is doing short term, working with the local authority, providing temporary protection, sandbags, flood bags, and the clearing up, all what we did in the January, February last year. But they are only short term measures. Again, the department will do its best to help, but what we're saying around the island, it's very much down to the property owners to try and also protect their own property. We can do the large scale works, but again we need local people putting local protection in place. What would be the next steps? Like I say, the key to today is we want feedback from yourselves as to whether any of the options that JVA are going to talk through are the options you would consider. Are there other options? Do you want us to progress any of these options? If you do, what's the consensus of opinion on the options? We would then get the local feedback and then start progressing through the capital expenditure. We'd obviously have to get political will to spend the money, business case of Treasury, then start looking at a detailed design, the planning issues, the tender process, impacts on the environment. So we are at the very, very early stages. This is very early consultation. Nothing has been agreed. We've asked JVA to come up with a series of options. So if I could now hand you over to JVA and they'll talk you through the options, we can then answer any questions or queries you've got at the end, if that's okay.
Thank you very much, Alan. By way of an introduction, JVA Consulting are a civil engineering consultancy, and I specialise in coastal engineering design. I'm a chartered civil engineer. My colleague Alec here as well has been working on the project. He's also a specialist coastal engineer. I'm going to just run through the study briefly with you, so give you a bit of background to it, the summary of the approach that we took to look at the options. I'll run through the harbour options we looked at, and then the open coast options, and then we'll present some conclusions. So the study actually included 7 sites across the island, of which obviously Laxey was one of those. We considered 2 types of risk mechanism that affect Laxey. So we looked at the still water level risk. For those of you who aren't familiar, still water level comprises both the tidal risk element, so that's the astronomical part, but also the meteorological part. So that would be if there's a low pressure system, then you may get a storm surge. So those 2 components work together to give you your still water level. We also then looked at the wave overtopping risk. So for the harbour sites that we looked at, so within the harbour it was solely still water level, although we did make some allowance for waves, as we understand waves do propagate into the harbour. And then for the open coast part of Laxey, we looked at both the combination of the still water level and also the wave action in combination. We looked, or the intention was to try and develop 3 types of option for both the harbour frontage and also the open coast frontage. In the end, we've only been able to come up with 1 suitable option for the harbour frontage, mainly due to the constraints of the site itself, but Alec will run through that with you in a little more detail. For the open coast frontage, we have developed 3 possible options that will improve the standard of protection against wave overtopping considerably for Laxey. This image just shows the extent of the 2 areas that we looked at. Obviously you're familiar with both, so we have the open coast there in blue and then the harbour area in red. I'll run through briefly some of the design criteria that we've used to help develop these options. So the target design life for all of the options that we've developed was 100 years. The standard of protection we've looked to develop was for all of the defences to be structurally stable for an event that has a return period in excess of 1 in 200 years. So the chances of having a 1 in 200 year event annually are 0.5%. So you have that risk every year. I think it's quite a hard concept to understand sometimes. Possibly a good way to think about it is rolling a dice. So if you roll a dice once, you might get a 6. It doesn't mean, which is a 1 in 6 chance, it doesn't mean if you roll the dice again you won't get another 6. So I think it's important to think about these return periods in that way. A 1 in 100 doesn't mean if it happens this year, it won't happen for another 100 years. It just means you have a 1% chance of that event occurring annually. For the harbour sites, we've developed options that will provide you with a level of protection for a 1 in 200 year still water event, and we've also included climate change within that. So the current predictions for sea level rise are that it will rise in Laxey around about 650 millimetres over the next 100 years. So the options we've come up with include that 650 millimetres that takes you to the year 2115, and also that very rare event, that 1 in 200 year event in that year 2115. So it's a high standard of protection that we've been looking at initially. Similarly, for the coastal sites, it's a 1 in 200 year still water event in combination with wave action as well, through to the year 2115. I'll run through in a little more detail the wave overtopping element of this. So this is only applicable to the open coast part of Laxey, but we've come up with a twofold threshold for the designs we've developed. The reason for this is just to try and offer a more pragmatic solution. So what we've tried to do is we've come up with a stringent level of wave overtopping that would be acceptable for the more frequent 1 in 1 year event. So the type of big storm that you'd expect to get every year. We've developed designs that will limit wave overtopping to 0.1 litres per metre per second, which is the standard industry method of measuring wave overtopping. If you can think about 0.1 litres, that's like a small cup of water being thrown over a wall every second. For the very rare, the extreme 1 in 200 year event, we've allowed a little more tolerance on the volume of wave overtopping that could occur. So that has been increased to 10 litres. So that's a bucket's worth. The reason for doing this is we could design a wall that would provide you with that very stringent 0.1 litres for the very rare event. The impact of that is though that that wall would have to be very high to achieve those standards. The table at the bottom provides a bit of context to that. So that 0.1 litres, this is industry standard guidance, this table. So the 0.1 litres is considered to be safe for aware pedestrians with a view of the sea. So you could be out there in your wet weather gear and you get splashed a bit, but it will be in no way dangerous. The 10 litres, you probably wouldn't want to be out there, but it would be safe for, say, members from the council, from the government, to be out there who were doing sort of works in that area. So the public would be discouraged from being at the rear of those defences, but it would be safe for trained personnel. So that's what we've used to develop these options. These images here just show you what we've done, or part of the process that we've used to develop the designs. So we've used two types of computer model. The first type brings in waves from a long way offshore. The image at the top there shows, the little dots show every point where the computer model looks at wave height. So that brings all these waves in from all around the island to the nearshore environment, so just offshore from Laxey. Then we use another wave model, this is the bottom left image, that we can, within the computer model, we can put in our defence designs. So this is just a schematic in the bottom left there, but it shows a small wall. So we can run through numerous defence options and iterations, so we can raise the height of the wall, we can set it back, and the computer model will tell us what the impact of that will be on the volume of wave overtopping that you can expect. So then that allows us to finally determine the height of the flood defence wall that we're going to design. We've then been through a process of options appraisal. So we've looked at 3 different categories to try and assess which of the options we think best meet the criteria. The 3 broad categories were technical, environmental and social, and economic, which covers the cost of the scheme, both capital and maintenance cost. When we've done this initial assessment, we haven't put any weightings to these categories, so they all have an equal weighting. It might be that from the discussions with you as members of the public in Laxey, some of these factors need to be weighted more highly to help you make that decision on what you think is the best way forward. But at the moment, we've given them all an equal weighting, and that has helped us determine which we think are the preferred options for Laxey.